Hi guys, welcome back to the last example on this section on solving trig equations. Guys, this is number 10. There's already almost 9 problems before this that I have solved on my YouTube channel. Please go back and look at them. Guys, this is completely different than any of those problems. These were like 10 different types of problems that I'm sharing with my students here. Okay, so here we have a cosine inverse, and there's cosine inverses on the right hand side as well. So far all the 9 problems or examples that we did had just a regular trig function. This is the first example where there's an inverse function, so I also wanted to share this one with you as well. Guys, it may seem very complicated, but it is not that complicated if we remind ourselves some basic things about the inverse function. So guys, I'm quickly going to remind you this quick thing from the section on the inverse trig functions. Guys, if we have a cosine inverse x equal to theta, if we set that equal to theta, now there's an equivalent way, or I like to think of that as an easier or user-friendlier way of actually expressing that same equation. And that way is, guys, that x equals to this cosine of theta. So you can either express this information like this, or you can express it like this, the second form. But the second form is like an easier way of looking at this particular equation. So one of the ways sometimes people like to think about this is they kind of take the cosine or apply the cosine on both sides. So then they think of this as cosine and cosine inverse, or basically they are inverses of each other. So they kind of cancel out and they are left with x on the left hand side, and on the right hand side obviously you will be left with just the cosine of theta. So that is one of the ways of thinking about it. And guys, we have already in the section on simplifying inverse trig functions, we have already discussed this basic method of going from this form to this form, that they are equivalent forms. So guys, we can just use the same idea for this particular equation, and that will at least get us started, and then we have to use some other methods and techniques. So if cosine inverse x is this whole piece, so we can think of this whole thing as a theta. So if I consider this whole thing as a theta, then what would be my x? So x would simply be the cosine of theta, but here my theta is not just one single term, it is these two terms. So I'm going to write both of these terms here inside the parentheses. Well, these are two terms, that's why I should put it in the parentheses. That is my first step, and this step is very essential in order for us to actually go ahead and solve for x. Now again, this function still does not look pretty simple. It is still a complicated function. Now we have to figure out how to simplify this function. Guys, one of the ways to simplify this function is to kind of go back and recall the cosine of the difference formula, cosine of a minus b, because we can think of this as a and this as b. Guys, we cannot just distribute this cosine. That would be completely incorrect. We don't do that here. We are not going to do it here as well. So what is the formula for the cosine of the difference? Guys, if you remember, that's great. If not, please look at the formula sheet. Cosine of the difference is cosine a, cosine b, and then there's a plus sine a and sine b. So we have to use this form to simplify this right hand side. So x will be cosine of the cosine, because this is a, this is b, so cosine of cosine inverse 3/5, and then times cosine of b. B is sine inverse 4/5, that is the first half, and then plus, let us write the second half. Guys, second half is sine of a, sine of the cosine, which is sine of cosine inverse 3/5, and times sine of the b, which is sine inverse 4/5. Okay, guys, I need more space, so I'm going to get rid of some of the information here. So I'll get rid of this. So you know what, I want to write this in one straight line. So this is 3/5, and this is sine of the sine inverse 4/5. Okay, good. Now simplifying further, guys, we know cosine and cosine inverse, if this is in the 3/5 is in the range of the cosine inverse function, that which means it is in between -1 and 1. What happens? This just cancels each other out. We are left with 3/5. Now this we cannot just cross it out, so we have to do some extra work. First we have to evaluate this, and then from there we can find the cosine. Guys, same thing here, we cannot just cross out anything, we have to do some extra work, but this we can simply simplify this, because 4/5 is also between -1 and 1. That means this will cancel each other out. So I will have this, I'm just going to rewrite cosine of the sine inverse 4/5, and then this is sine of the cosine inverse 3/5, and guys, this is going to be times only 4/5, because sine and sine inverse will kind of cancel each other out, cross each other out, right? So we have to simplify these two, and once we have these two, then we should be able to find the value for x. Now, how do we do this, guys? Again, we cannot see this on a unit circle. So what we do is, again, I have done this in my section on the inverse trig equations, but inverse trig functions, but I'm going to do it again. So what we do is we set this equal to theta. So we set this equal to theta. So if I set this equal to theta, that means I'm just evaluating cosine of theta, right? Similarly, guys, this guy, I'm going to set it equal to, I'm not going to set it equal to theta because I use theta for this one. So for this guy, I'm going to set it equal to another angle. Let us call that pi. Okay, you can use alpha, whatever you like, guys. I'm going to use pi. So if I use pi here, that means this whole thing can be replaced by pi. Okay. So our goal is now to find cosine theta and sine phi, and then we can replace the values and then simplify. Now, if this is equal to theta, that means, what is sine of theta? Sine of theta would be just 4/5. Similarly, if cosine inverse of this is phi, then cosine of phi will be 3/5. From here, guys, one has to just do some basic trig stuff, which is like sine theta is 4/5. We want the cosine theta. Now what do? It's like very basic things that we learn when we start learning about the trig functions. We draw a reference triangle. This is positive in the first quadrant, so just a regular right triangle in the first quadrant. This is my theta. Sine is opposite over hypotenuse. This is 4, this is 5, this is a 3, 4, 5 triangle, or you can use the Pythagorean theorem to find the missing side. So this will be, adjacent will be 3. What is the cosine? Cosine of theta is adjacent over hypotenuse. So I can replace cosine by adjacent, which is 3 over 5. Guys, this is a coincidence that this value and this value is the same, but I mean, it can be different. It all depends on what this value is. 4/5, it could be something completely different. So the value would be, this ratio would be different, okay? Now we do the same thing with this guy. Here I have to work with the cosine function, but it is positive in the first quadrant. So let us again draw that reference triangle. This is angle phi. Cosine is adjacent over hypotenuse, so we got to find the opposite, which is going to be 4. It's basically the same triangle, right? It was kind of a same triangle. Now from here, we can write the sine of phi, right? Sine of phi would be opposite over hypotenuse, so it's 4/5. Okay, this is 4/5. We have all the values. Let us simplify and get the final value for x. So 3 times 3 is 9 over 5. Sorry, 5 times 5 is 25. And then 4 times 4 is 16 over 25. Guys, we can simplify because we have the common denominator. We can add the numerator, 16 plus 9. 16 plus 9 over 25 is 25 over 25. Guys, the final value is 1. And if you want to verify, you can go back and put it back here, or you can use your calculator to see that the left hand side will actually be equal to the right hand side. So guys, this is how you solve inverse trig functions. I only showed you one example on this, but I mean, I think that should be good enough for you to give you some like clue how to deal with the inverse equations, inverse trig equations. Please guys, practice more of these and the other types that I have shown in my first 1 through 9 examples. Again, if you have any questions, feel free to reach out to me. Guys, till next time, take care. I will see you with another concept in my next video.